What is gravitational field? Before understanding the gravitational field, let's look at an example, which almost all of us have done in our lives. Once you understand the example I shared with you, it won't take you long to understand the gravitational field. When we place a nail next to a magnet, we see that the magnet attracts the nail. But the magnet can attract the nail only when the nail is kept within a certain region of that magnet. If the nail has been placed some distance from that certain region, the attractive force can no longer affect the nail. That region is the region of the magnet, known as the magnetic field of that magnet. If we place a magnet instead of the nail, we can see the repulsion effect also. However, from this example, we can clearly understand that a magnet has a region in which the magnet can exert the force of attraction or repulsion. Similarly, in the universe, any object, it may be a planet, star, or anything, has a region where another object experiences an attractive force when it enters. That region is called the gravitational field. But here it should be remembered that, in this case, only attractive force acts, no repulsive force acts. For example, due to the gravitational field of the Earth, any object in this field experiences an attractive force towards the center of the Earth. Now if we want to define the gravitational field, then it can be defined as follows. The gravitational force acting on a unit mass of an object, at any point in space due to another object, is called the gravitational field of that object. In physics, the gravitational field is a model that is used to explain the influences that a massive object extends into the space around itself. In reality, the gravitational field of any object extends to infinite distances, but the region after which the gravitational force becomes negligible, that region is no longer regarded as the gravitational field of the object. Now, it is important, not only to mark a region as a gravitational field of an object, but also to measure the gravitational effect at each point in that region. That is why we measure the gravitational field intensity at a particular point in that gravitational field. Measurement of the gravitational field intensity. From Newton's law of gravitation, we know that the gravitational force between two objects of masses capital M and small m, separated at a distance of r, is F is equal to g(m)m by r square. Now for an object of mass capital M, we need to determine the gravitational field at a distance of r from its center. So, if we take small m equals 1, then according to the definition, we will get the gravitational field due to the object of mass capital M at a distance of r from its center, and that is E is equal to g(m) by r square. So from equations number 1 and 2, we get E is equal to F by m. This is the measure of the gravitational field intensity. From the view of gravitation, this gravitational field intensity is identical to the acceleration due to gravity. So sometimes this gravitational field represents by g, that is, g is equal to F by m, or gm by r square. Since force and acceleration are both vector quantities, the gravitational field intensity is also a vector quantity. The direction of this field intensity is always worked towards the center of the object. Unit of gravitational field. From equation number 3, we can write the unit of the gravitational field is equal to the unit of force divided by the unit of mass. So the SI unit of gravitational field is Newton per kilogram, or meters per second squared. And the CGS unit of gravitational field is dyne per gram, or centimeter per second squared. Dimension of gravitational field. From equation number 3, we can also write the dimension of the gravitational field is equal to the dimension of force divided by the dimension of mass. That is, mLT minus 2 divided by m, or LT minus 2. So the dimensional formula of the gravitational field is equal to m0 L1T minus 2. If you enjoy our videos, then don't forget to like, share, and subscribe.